some more examples for solving. Okay, I didn't realize we can solve via graphing. So in this case, we have 3 halves x plus 1 equals 4, comma, y1 equals 3 halves x plus 1, and y2 equals 4. Second example, 3 halves x plus 1 equals negative 2, comma, y1 equals 3 halves x plus 1, and y2 equals negative 2. Notice the subscripts 1 and 2 just implies that we have two equations. So in reality, notice that the first part of both equations are identical. So they're actually the same expressions that we're trying to graph, with the exception of the 4 and the negative 2 on the right side of the equal sign. And notice what follows. The y1 on each one of those is the left side of the equal sign. So we have the equation 3 halves x plus 1 is repeated for both of them. So it's the same equation on the left side. But on the right side, we have the 4 and the negative 2. Okay? So, let's try our expression or first equation, the one that has 3 halves x plus 1. And from just looking at the plot, we'll try the y equals 4 and y equals negative 2 in a minute. But for now, let's stick to the y equals 3 halves x plus 1. And realize that y equals mx plus b. That's the slope-intercept form of our linear equations. So m is the slope, and it's in the form of rise over run typically. And 0 comma b is our y-intercept, which means that the v-value is the v-value for our y-intercept. So, in this case, our slope equals 3 halves. So rise of 3, run of 2, up 3 over 2 in other words. Our y-intercept, from looking at the formula, we can see that x value is 0. The y value has to be the v there, which is positive 1. So there's our y-intercept. And to remember, the y-intercept is the starting point in our graph. Okay, so our slope says up 3 over 2 as a reference. Do keep that in mind. So, we can always do a quick sketch. You're welcome to do a hand sketch. Hand sketches are totally fine. So, label our x and y axis at the very minimum. And plotting using the y-intercept, 0, comma 1. There's our y-intercept location. It's our starting point. And we're going to go up 3 over 2, and that gives us our next dot. Up 3 over 2 gives us our next dot. And you can continue graphing up 3 and over 2 to get your next dot, etc. So likewise, you can connect the dots at the end. Do notice we have open arrows at the left side and at the right side of our graph. That implies our line will continue to the left and down forever, and to the right and up forever. So in other words, it's a continuous graph. Okay, so now let's try graphing y equals 4, which just implies that the y value is always 4. So it's a straight horizontal line at y equals 4. That's a red line there. And y equals negative 2. Once again, that's a horizontal straight line because y is always equal to 2. There it is. And now let's check and see where they cross each other. Where do our non-horizontal lines, the one that's going up from left to right, intersect each one of our horizontal lines, the ones that are essentially flat. Okay, looking at the first equation of y equals 4 versus our full expression or equation y equals 3 halves x plus 1. From the graph, we can tell that our crossing point occurs at x equals 2, and the y value once again is 4. So we can state it as two separate answers. X equals positive 2 and y equals, well, positive 4. Or we can also do it as a coordinate now, since it's a coordinate location. It's a single point. The x value being 2 and the y value is 4. So 2 comma 4. And let's once again do it for the other one. Okay. Doing it for the other equation. Y equals -2. Okay, x equals -2 and y equals -2 is our parent location. So once again, we can do the same as before and give our answer separately as x equals -2, y equals -2, or as a coordinate, -2, -2. So there are our crossing points or solutions to both of those questions or expressions.